Welcome to the AI Research Roundup. I'm Alex. Today we are looking at a paper from the Hugging Face trending list, published on August 20, 2025, just 2 days ago. The big hook is that this paper launches a rigorous benchmark where large language models must use real model context protocol servers, and even frontier systems like GPT-5 score only 43.72%, Grok 4 hits 33.33%, and Claude 4.0 Sonnet reaches 29.44%. The paper is titled MCP Universe, Benchmarking Large Language Models with Real-World Model Context Protocol Servers. And as we will see, the implications for real tool use are pretty sobering. Beyond headline scores, the work spans 6 domains with execution-based evaluators, surfaces long context and unknown tools failures, and ships an open-source framework with a user interface for adding agents and servers. Also, the authors shared a GitHub repo. You'll find a full framework for building and benchmarking MCP-enabled agents, with docs, ready-to-run tests per domain, YAML configs, a Gradio dashboard, fast API backend, Dockerized MCP servers, and example tasks. There are agents, workflows, LLM integrations, tracing, reporting, and scripts to run individual or batch benchmarks. Alright, this figure shows a full MCP agent workflow, from user instruction to execution-based evaluation. On the left, you can see the stack of MCP servers and the agent loop of actions and observations, which sets up the tool space. The right side walks through the Google Maps task, where the agent geocodes 2 hotels, searches restaurants, then calls a distance matrix to compare drive times. The final blue box delivers the answer, and the evaluator checks it against real server results. Next, this table compares recent MCP benchmarks on 3 axes: real-world integration, temporal dynamics, and execution-based evaluation. The rows show that MCP World integrates with real systems but lacks time-varying tasks, while MCP Radar and MCP Eval miss either real integration or execution checks. Live MCP Bench adds live data but still skips execution verification. The bottom row highlights the contribution, which combines all 3 dimensions for a more faithful assessment. Building on that, this figure lays out the end-to-end evaluation pipeline, showing how a user instruction flows through agent configuration, tool calls, and automated checks. The left block configures the language model, the agent style like React, and the chosen MCP server, which together define the tool space. The center panel shows the final state text produced after interacting with Google Map tools. The right panel lists execution-based evaluators that verify content, format, and task-specific constraints, so the pass or fail result reflects real server responses. Now we have the main comparison table, which reports success rate by domain, plus overall success, average evaluator score, and average steps. You can see GPT-5 leading overall at 43.72% success, with a 60.23% average evaluator score, though it needs 8.22 steps on average. Grok 4 follows at 33.33%, while GLM 4.5 tops open source at 24.68%. Domain rows highlight strengths like GPT-5 in financial analysis and Grok 4 in browser automation. Moving to the results, this figure contrasts long context growth and the impact of stepwise summarization. The left panel shows average input tokens rising steeply with more steps, especially for browser automation, which quickly climbs past 80,000, while location navigation spikes late and financial analysis grows steadily. The right panel reports success rates with and without a summarizer, where gains appear in location navigation but shrink or reverse in browser automation and only modestly help financial analysis. So compression helps selectively, because it can drop details that downstream calls still need. Wrapping up from the long context analysis, 2 takeaways stand out. First, even frontier models struggle in real tool use, with correctness on execution checks being the dominant failure mode. Second, long horizon interaction creates a context bottleneck where naive summarization only sometimes helps. The open framework invites better agents, stronger tool learning, and smarter memory. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.